Okay, Algebra 1, Section 3.5, Arithmetic Sequences as Linear Functions. So our objective today, we're going to recognize arithmetic sequences, relate them to linear functions, and we'll do some work with the arithmetic sequence equation where you find the nth term. We'll get to that. Let's first talk about what a sequence is, some terminology here. It's just a set of numbers that are in a specific order. So we give you a set of numbers, they're in a certain order. That's called a sequence. If the difference between these terms is constant, then it is an arithmetic sequence. So constant meaning this difference stays the same. So maybe it always goes up by 2 or always goes up by 10. Whatever it is, you can find a pattern there where it stays the same. And then finally, the common difference. Common difference is the constant rate that it increases. Okay, or decreases. So increases we know is a plus. That means it would go up by a certain amount each time. And decreases would be minus, where it would go down a certain amount at the same time. And that's what we're dealing with, addition or subtraction. If it's a multiplication or addition, or excuse me, if it's multiplication or subtraction, what am I talking about? If it's multiplication or division here, then it's a different type of sequence, which we call a geometric sequence. Which you'll learn about probably in geometry. But this is arithmetic is add or subtract. So that's what we're going to be dealing with today. Okay, so let's jump in. Let's skip this one here and get with the table and just skip right into some regular examples. So the first one, determine whether each sequence is an arithmetic sequence. Explain why or why not. So this basically is a yes or no question. What we're asking you is a yes or no, and your explanation would be, is there a common difference or not? So we look at A, we can look at what's happening from -4 to -2, and hopefully we can see this is a difference of a +2. It's getting 2 times bigger. And then from -2 to 0, it also goes up +2, and from 0 to +2. So it's, and the dot dot dots means that pattern's going to continue. So because it's always +2, this would be a yes. And your explanation is showing that it's that it went up by the constant amount. Okay. Let's look at letter B. Okay, letter B here would be, okay, well now we got some fractions. So you're going to do some fraction work in your calculators here. What you should do is take the second number and subtract the first one. So 5/8 minus 1/2. Also take the third number, 3/4, and subtract the second number of 5/8. And then the last number, 13/16, and subtract 3/4. Your calculator buttons can somehow do that. If not, you're going to have to find a common denominator on those and try to do it. But what it should come out to here is that from 1/2 to 5/8 is a +1/8. And then from 5/8 to 3/4 is also +1/8. And then 3/4 to 13/16 is also +1/8. So this would also be a yes. And you can check the math on a calculator, or if you don't have a calculator function that does that, then you got to find a common denominator and add or subtract those. We'll skip C. We'll come back to that in class and C. I think you can figure that one out. And also both C's, the one down below, we'll skip that one and come back to it if we need to in class. The next one says find the next 3 terms of the sequence. So the first thing we're going to do is find out if there's a common difference, and if there is, it's telling us that it's an arithmetic sequence, so we know there's a common difference, and then just keep going with the next few terms. Well, in this one, this is the same one that we did above in A. It's the same one, so we already know it's +2, so we'd have to go the next few terms. +2 then would be 4, and then another +2 would be 6, and then another +2 would be 6, and then another +2 would give us 8. So the next 3 terms would be 4, 6, and 8, because the common difference was a +2. Okay? In letter B here, you can kind of figure out that the common difference here looks like it is 1.5, and I'm using D, little d, for the common difference, and it's a +1.5. So when we go ahead and add the next few terms, we're going to get, because it's going up 1.5 each time. Okay, so the next few terms, if we kept doing that, would be, it looks like 15.5 is 14 plus 1.5 is 15.5. 15.5 plus 1.5 is 17. And then 17 plus 1.5 would be 18.5. So those would be the next three terms. And we'll wait on C on that one as well. Okay? But I want to do some work here with this equation. So this one, let's first focus on the box. This is important. The nth term of an arithmetic sequence with a first term A1 and a common difference D is given by this equation. And n has to be a positive integer here. So this equation is going to look funky. We're just going to kind of work with it. It's got a lot of different terminology in it, but I think you'll get the picture of it. It's not too bad if you break it down piece by piece. Okay? So the equation here is, it looks weird, but a sub n, we call that a sub because it's down below, and that equals a sub 1 plus n minus 1 times d. And so what are these terms? Now a sub n, we could use this as y. We could use it as y, but you know, we don't have to. I think a sub n is what we're looking at. Because what this tells us is that if we use the nth term, what that tells us is that we can kind of figure out any term you want, and we'll get this equation. We can plug in a term there, and you should be able to find out what it would be based on this equation. The first term we know here is a sub 1. That's going to be the first term here. And I'm just going to highlight that because I think it's kind of important to make sure we point that out, that this is the first term, a sub 1. That was sub 1 means the first term in the sequence. And then we've got our common difference over here is our common difference. Common difference. So that's that pattern. That's that pattern of, does it go up by 2 each time? Does it go up by 3? Does it go down by 4? You know, what is the pattern that we have? Okay, and then n is the number that we're either trying to find or they're going to give us one like that. So just keep that in mind with this equation. So we're going to use this equation, and we're going to write an equation here for the nth term of the arithmetic sequence, where it's got negative 49, negative 35, negative 21, and negative 7. So let's first find the common difference, because that might be our biggest help. What is the common difference between this? We know it's an arithmetic sequence, so we know it's going to have a common difference. In this case, we add 14 to get to negative 35, and then negative 35 to negative 21 is another addition of 14. And so our common difference is going to be a 14. So that's going to be our D value. So we already know our D value is going to be a positive 14. Okay? And then we can also find out what's the first term in the sequence. We know the first term because it's listed right here. That's the first term. First term is negative 49. So we have some information to plug in right away. So let's use this equation. I know it looks weird, but just keep it in there. You'll get used to it as we roll on here. So a sub n, we're going to just kind of use this equation up in the box and bring it back down. Keep focusing up there. So a sub n, and that's going to equal our first term, a sub 1, which we already know is negative 49, plus we've got n minus 1 times d. And we don't know what n is yet. N minus 1 times our d, our difference of 14. Okay, well, what do we notice here? We have a distributive property, okay, because we've got parentheses and we've got the 14 on the other side. And it is okay to rearrange these two and put the 14 in front, and sometimes you really see that distributive property come out for us. Okay, so let's do that distributive property and rewrite our equation down below. Okay, so the next one, what are we doing here? We're going a sub n, nothing's changed there, equals, now we've got the negative 49 that nothing has happened to. We're just bringing that straight down. And now we can distribute. 14 times n is 14n. 14 times a negative 1 is a minus 14. And there we go. Now I do see some things that we can combine here because of combining like terms. I'm just going to extend that a little bit for us so we have a little more room to work. But we do have some common terms here. We have a negative 49, which is a constant, and a negative 14, which is a constant. So we can combine those to get a final answer here of a sub n. And I'm just going to put the variable first because I can do that, 14n. And we combine that negative 49 and negative 14 to get a negative 63, and that would be our equation. So if we were trying to find like the 10th term, we could plug in a 10 in here, and we would get that 10th term, which we'll do in the next example. But that was just getting the equation and figuring that out. All right, so this example here, we'll do one of these, and we can do a couple in class, and then we'll set you free. But this one takes a little while because we've got a lot of things here, A, B, C, and D, to find this out. So first thing says we're going to write the equation. And they've got a graph here, which we'll be able to graph it. And graphing is not that tricky. It's not that important. We'll, you should be able to figure it out. It's not that bad. But they're going to ask you to do it. That's why we put the graph there. Okay, so again, here's our equation. We've got A sub n. I'm going to put it at the top here. Equals A sub 1 plus, and I'm going to just rearrange it. Hopefully no one minds that and going D times n minus 1, because all that does is just kind of alerts us that there's a distributive property that's going to take place in there when we get that opportunity to do it. Okay, so that's our equation that we start with. And again, remember what the two key terms that we're looking for here is the first term here and the difference, the common difference. So if we can find that one right off the bat, then we'll be in good shape. All right, so there's our equation. They want the equation for the nth term in the sequence, -4, -8, -12. So what is our common difference here? Well, if we can find it, what's happening here? We're going backwards 4 each time. So our D value is going to be -4. And our first term we know is 0. So that's easy to write down there and say, well, first term is 0, and the common difference is a -4. Okay, so that should help us get our equation started, and let's go ahead and use it. So we're going to say a to the nth power equals our first term, which we know is 0, and we're going to write it down. We don't even really need to because it's 0, and then we're going to go with a plus the common difference, which is -4. So I can really actually put a -4. I'm just going to keep it as a plus -4 right here so far. And then n minus 1. And that kind of really shows us that we have distributive that we're going to have to come up with. All right? So the a sub n is just going to come down here. We don't even have to write our 0 anymore. I'm going to, just for fun here, just to keep working with it. We know this is -4. Now I can go ahead and distribute -4n. -4 times n is -4n. And then we've got -4 times a -1. So be careful with your negatives, because -4 times -1 makes a positive 4. And now I'll rewrite it down here without the 0, because we don't need that anymore. With common term, we should see the 0 and 4 make 4. So our final equation here would be -4n plus 4. Would be that equation. Okay? So we're going to write that up here in our answer. A sub n equals -4n plus 4. So that's our answer to A. We've finished that one up. Okay? So that's part A right here. Okay. Now let's move on to part B. Part B down here. And what part B asks for is, it says find the 9th term in the sequence. So here we can use this equation and plug in this 9th term. That is n. That's the nth term. That's what they're talking about. So we can plug that in to our n here and get our answer. So in this one, I'm going to take my a sub n, but instead of putting n, now I'm going to put 9, because they want the 9th term. And now I'm going to say equals -4 times 9, because that's the n value that we're working for, and then plus 4 here. And now it's just simple math here to figure this one out, that I've got -4 times 9 is a -36, plus 4 is a -32. So up here for the B, my nth term is -32. Okay, part C. Part C, we're going to go over to the graph. Okay, part C, we're going to go over to the graph here. And really what they want is the first 5 terms. It's really not that difficult to do, so we're just going to make an XY table. And your x value, remember that this is also, this part here can be your y value. So those are the terms in the sequence. And your x value, we're just going to say x is the number of terms. So when we make our x table, this is the first term, second, third, fourth, and fifth. So your x value, remember, when we're talking to x's, these are the terms. And your y is going to be the actual numbers in the sequence. So what are the first 5 numbers? Well, we know 0 is the first one. We know -4, -8, and -12. And we can continue that pattern by subtracting 4 and get -16 here for the 5th term. And we just graph those. We just graph them. So x is 1, y is 0. That's going to be right here. And then the next one, 2, -4. Going to put us here. Then 3, -8. So 8. And then 4, -12 is going to kind of be off the map here. Somewhere down here. Okay. And then we could keep going with 5 to 16, but the graph's pretty easy, just plotting points, so you don't have to worry too much about it. Okay. So that's part C we did over on the graph. And now we're left with part D here. What term of the sequence is -68? Okay, so in this one, what we're going to try to do here, what term is -68 is, if we can now plug in the whole term, I guess let's use blue here for part D. Okay, so now if we plug in that whole term, again, we're going to use the same equation, so I'm just going to pull this equation over here and say a sub n equals -4n plus 4. So now they want to know what is -68. So what term is that? So I'm going to plug that in, not for n, but for this whole term here, and make it -68 over here. Okay, just substitute that in. And then we're going to basically solve for n to find out, hey, what term is -68? I've got my plus 4 here. So how do I go about solving this algebra problem? Basically a 2-step algebra problem. Just subtract 4 from each side. So now these side we know cancel out, and we're left with -4n on the right side, and the left side goes up to a -72. And then when I divide through by 4, or a -4, hopefully you caught that, then I end up with n equals 18. So what that says is that -68 would be the 18th term. The 18th term in that sequence. And you could go ahead and figure that out if you kept going and subtracting 4 each time. You did do it 18 times. Here, this equation gives us an easier way to find that. Okay. Example 6 is very similar. We can come back and look at this in class. And then same with example 7. A little bit of a word problem here with this one. A little less to do it, but we'll look at this one in class as well. And so that's going to kind of take us to our lesson summary. What is the formula to write an equation of an arithmetic sequence? We should have looked at it. That should be easy to figure out. And then this one, the practice problem here, a couple-parter. We've got our sequence up there, 7.2, 4.3, 1.4, ... What's the common difference? So we can just add or subtract to figure out what the common difference is there. What is the first term? That should be easy enough. And then write the equation of the sequence in that equation that you used for the lesson summary part. Just plug in your first term, plug in your common difference, and we should be good to go. So I know it's a little tricky at times, but stay with us, and we should have no problem with that. We'll go over some more in class, bring some questions here. But good job today, and we'll get to work on this tomorrow. Thanks a bunch.